So in this chapter, we are going to learn how to construct a confidence interval for one population mean, right? And before I tell you what is a confidence interval, how we develop a confidence interval, what are the methods, what are the steps involved, so we need to learn few basic definitions. So first we review, or we very briefly see what is the inferential statistics. What is inferential statistics? I told you in chapter number 2. The statistics in which we estimate something about the population based on the sample data, right? So we want to know something about the entire population, but the problem is that we can't access the entire population due to the reasons we don't have a time, we don't have a manpower, we don't have resources to do that. So instead of accessing the entire population, we go to the sample, we select a sample, a small part of that, and then we try to make a prediction, and then we try to make an estimate, or then we try to make an inference about that property of the population. And that property may be the population mean, the population standard deviation, or the population proportion. Now, in order to understand few basic terms at the beginning, let's understand a scenario. By putting you in this scenario, I would like to move my discussion forward. Let us suppose I ask one of my students in my class, can you tell me what is the average height, mean height of all the male student of the Berkeley College? That's the question I put to my class. And in this question, the research question which I put for my class, the population of my interest is all male students of the Berkeley College. What is the variable of interest? The heights of the male students. And what I want to estimate the average height, the mean height of the students. I want to estimate mu. That's the population mean, right? So what I do, the first student raised the hand, let's say, and what he does, he said, oh, Professor, what I have done, I have selected a sample, let's say of 10 students. I have 10 students, and from the sample of 10 students, I have an estimate, and my estimate says the average height of the students in the Berkeley College is 66 inches, right? So what he has done, actually, he has selected a sample. This is a sample of 10 students, and from that sample he come up with this estimate. This is actually the sample mean, and now he is on the base of this sample mean, he is saying, I think the average height of all students of the Berkeley College is 66 inches. Now what he has done, he has just studied a sample, and now he is trying to estimate about the population mean. That's what the first student said to me. Let's say another student raised his hand, and he asked me, Professor, I have another idea. I have also sampled the 10 students. Let the sample size is 10. And I come up with the following estimate. I think estimate is from the average height of all the students is from 64 to 68 inches. Now look at what the answer he gave me. He never gave me a single value, rather he gave me a range of value. It's a range of value. Look at that, range of values. The first student gave me an estimate with the help of a single value. This was a single value. And now the second student gave me an estimate not by a single value, but rather range of value. He said, okay, I think from what I studied, what I sample a 10 student, and I predict, I do some math. For right now, we're not worried how he did math. Right now, he gave an estimate. That estimate is from 64 to 68 inches. Now look at the third student, what the third student come up with. He said, Professor, I did the calculation also by using a sample of 10 students, and I think the average height of all the students is between 64 to 68 inches, right? And look at what he said after that. And I am 99% confident about it. Confident about it. Now I ask you guys to pause this video and look at the 3 replies of the students. This is very important that you understand the situation. I'm trying to teach you something. I'm trying to this discussion to lead to some new definition and some new ideas that I want to tell you. So pause this video and think about it, what you understand out of this. Now, look at the first estimate. The first estimate was an estimate that it's a single value estimate. The student estimated the average height of all the students of the Berkeley College by a single value. Such an estimate is called a point estimate. Such an estimate is called a point estimate. So it means if you estimate something, if you estimate a population parameter by a single value, then such an estimate is called a point estimate. You are estimating a population parameter by a sample statistics. You are estimating population mean by a sample mean by a single value. Such an estimate is called a point estimate, right? So this is the point estimate. So remember, the sample mean x bar, which is a sample mean, is a point estimate, of population mean. Okay, let me write point estimate for mu. That's what I want to write. Now look at what the second student said to me. The second student said to me, okay, I sampled the 10 student and I think the average height of all the students of the Berkeley College is in this range. This is called an interval estimate. Why? Why this is called an interval estimate? Because it's not a range of value, rather it's not a single value, it's not a single value, rather it's a range of value. And such a range of value, we call this an interval. So let me write it like this: 64, 68. This is an interval estimate. Now look at the answer of the third student. What the third student says, I think the average height of all the students is between 64 and 68, and I am 99% confident about it. He not only gave me an interval of estimate, but on the top of this, he gave me a confidence level. He expressed a certain confidence level, and he was 99% confident about it. Such an estimate is called a confidence interval estimate. So such an estimate is called a confidence interval estimate. So I repeat this once again. If you estimate something, if you estimate a population parameter by a sample statistics by a single value, then such an estimate is called a point estimate. If you estimate population parameter by a range of value, it's called an interval estimate. And if you estimate population parameter by a range of values, and on the top of that you provide a certain level of confidence, then such an estimate is called a confidence interval estimate. Now, what is the goal of this chapter? In this chapter, we develop technique for estimating the population mean by using sample data. We will see how to estimate the population mean by using a sample data, and that estimation will consist of finding the confidence interval for one population mean. Let's see how we do that. So estimating population mean when the sigma is known. This is the case number 1. This is the first case we are learning how to estimate the population mean when the population standard deviation is known. Case 1. We will see the second case when the population standard deviation is unknown. So what are the basic requirements or basic assumptions? Number 1, we have to have a simple random sample of size n. That's the first requirement. So before we construct a confidence interval, these are the basic requirements that needs to be met. First, we have to have a simple random sample of size n. Number 2, the population standard deviation, which is sigma, must be known. And number 3, either the sample size, n stands for the sample size, is greater than 30, or the population is normally distributed, right? Either this happens or this happens. And if you recall from earlier chapter number 7, sampling distribution, these two conditions, if any of these two conditions will ensure that our sampling distribution is normal. That is actually what we want to make sure. We want to make sure that our sampling distribution is normal, so that we can apply the normal theory, the Z distribution theory, which we already learned in chapter number 6. So this will ensure that the sampling distribution is normal, and this is guaranteed by central limit theorem. And remember that the x bar, which is the sample mean, is the point estimate for the population mean. Now, in this particular chapter, I will talk about the three confidence level, and these three confidence levels are 90%, 95% and 99%. Okay, these are the three confidence level which we will see often, right? Out of these, even 95% is most frequently confidence level. So if the confidence level is 90%, then the alpha, which is called the significance level, this is called significance level. Alpha is the significance level, right? And this is 10%. If the confidence level is 95%, the significance level is 5%. And if the confidence level is 99%, the significance level is 1%. Remember, the confidence level plus the significance level always makes 100%. They are complement of each other. And remember that if the confidence level, there are certain critical values, what we call it as a Z alpha by 2, and this is represented by Z star, which is called a critical value. If the confidence level is 90%, then the critical value is 1.645. If the confidence level is 95%, then the critical value is 1.960, and if the confidence level is 99%, then the critical value is 2.575. Now you might be wondering from where I get these values, right? These values we already learned in chapter number 3. Let me make a very brief discussion here. Let's say my confidence level is 90 and 95%, right? With 95%. So what I want to find the value of this value such that the area on this right side is half of the alpha. This area is alpha by 2. This area is alpha by 2, right? Half of this significance level. So this will be equal to 0.025 if you make the half of the alpha. So what you are going to do now, you look at the table and you find this particular area, the area on the left side. And if you look at the table and you find the Z-score for this one, you are given this area and you are going to look for the Z-score that has corresponding value. So this Z-score comes out to be 1.960. If you look at the table, we have done this in chapter number 6, how to find these critical values, right? So this is the critical value for a 95% confidence level. Then you can also use this. You can also find these critical values by using Excel. Okay. So basic steps for creating confidence interval. There are 4 steps. You have to remember those 4 steps. Number 1, first you check all the basic requirements. What are the basic requirements? Number 1, you have to have a random sample. Number 2, population standard deviation must be known. Number 3, either the sample size is greater than 30 or the population is normally distributed. These are the 3 conditions, 3 basic requirements that you need to check in the first step. If all these requirements are met, your first step is good, and then what you do, you move forward. If any of these conditions is not met, then you cannot move forward. Second condition, you decide the confidence level of your choice and pick the corresponding critical value, right? So you decide what is the confidence level and you find what is the critical value. And I told you in the previous slide what are the possible critical values. In step number 3, you find the margin of error. You have this formula. The margin of error is given by Z star, critical value, times the population standard deviation divided by the square root of the sample size. This is the formula to find the critical value. If you are not happy with the hand computation, then you can use a Microsoft Excel, this formula to find the critical value. And once you have found this margin of error, then what you do, the final step, you write the confidence interval. And what is the formula for that? Sample mean plus minus the margin of error. Or you can write x bar minus E or x bar plus E. I hope you understand that. Thanks for watching.